Imagine a computer that doesn't just process information, but creates things. Imagine it composing music, painting pictures, or even writing stories. This is the magic of generative AI, a fascinating realm of artificial intelligence that's changing how we think about creativity. Generative AI is like giving a computer a set of building blocks and teaching it to build. These building blocks are data, and the teaching happens through sophisticated algorithms. By learning patterns and structures from existing data, generative AI models can generate new, original content that's often indistinguishable from human-created work. This technology is rapidly evolving, opening up a world of possibilities. From generating realistic images and videos to composing personalized music and writing compelling narratives, generative AI is blurring the lines between human and machine creativity. But how does it actually work? Let's dive into the fascinating world of algorithms that power generative AI, exploring their inner workings, strengths, and limitations. Imagine teaching a computer to see and understand images like we do. That's what convolutional neural networks, or CNNs, are all about. They're like the eyes of many AI systems, especially good at handling images. CNNs work by breaking down an image into smaller parts, like putting a grid on top of it. They then analyze each part, looking for patterns and features like edges, textures, and shapes. This layered approach helps them understand the image's overall content. This ability makes CNNs super useful in various applications. Think of things like facial recognition in your phone, self-driving cars that can see the road, and even healthcare, where CNNs help analyze medical images for faster and more accurate diagnoses. The beauty of CNNs lies in their ability to process vast amounts of visual data and extract meaningful information. They're like detectives, meticulously piecing together clues to understand the bigger picture. However, CNNs can be easily fooled by slight changes in images, making them vulnerable to adversarial attacks. Plus, they require a lot of data for training, which can be a challenge. Language is a stream of information where words build upon each other to create meaning. Recurrent neural networks, or RNNs, excel at understanding this sequential data. They're like storytellers, remembering the past to make sense of the present and predict the future. Unlike traditional neural networks that process information in isolation, RNNs have a unique memory mechanism. They process each word in a sequence while remembering the previous words, capturing the context and relationships between them. This ability to remember makes RNNs ideal for tasks involving sequential data like language. They're used in machine translation, where they translate text from one language to another while preserving meaning and fluency. They're also behind chatbots that provide human-like conversations and voice assistants that understand and respond to your commands. RNNs are like the historians of the AI world, remembering the past to understand the present and predict the future of language. They're the reason why your phone can predict your next word or translate languages with impressive accuracy. However, RNNs can be difficult to train, especially when dealing with long sequences. They also suffer from a problem called vanishing gradients, where they struggle to remember information from the distant past, limiting their ability to handle long-term dependencies in language. Section 4. Transformers, the shapeshifters of language. What if we could understand language not just word by word, but by capturing the relationships between all words in a sentence simultaneously? That's the magic of transformers, a revolutionary architecture that's changing the landscape of natural language processing, or NLP. Unlike the sequential approach of RNNs, transformers process all words in a sentence at once, allowing them to grasp the context and relationships between words more effectively. They use a mechanism called attention to focus on different parts of the input sentence, giving more weight to important words and phrases. This ability to understand long-range dependencies in language makes transformers incredibly powerful. They've revolutionized machine translation, powering tools like Google Translate, and have led to the development of advanced language models like GPT-3, capable of generating human-quality text in various styles and formats. Transformers are like the conductors of an orchestra, coordinating different parts of a sentence to create a harmonious and meaningful whole. They're the driving force behind the increasingly sophisticated language models we see today. However, transformers' power comes at a cost. They require massive amounts of data and computational resources for training, making them less accessible for smaller companies and researchers. Section 5. Autoencoders, the masters of reconstruction. Imagine a machine that can learn to compress and decompress information without losing important details. That's essentially what autoencoders do. They're like master code makers, learning to represent complex data in a simpler form and then reconstructing it back to its original form. Autoencoders consist of two main parts, an encoder and a decoder. The encoder takes the input data, like an image or a piece of text, and compresses it into a smaller representation called the latent space. The decoder then takes this compressed representation and tries to reconstruct the original input. This process of compression and reconstruction forces autoencoders to learn the most important features and patterns in the data. This makes them useful for various tasks, like image denoising, where they can remove noise from images while preserving important details, and anomaly detection, where they can identify unusual patterns in data that might indicate fraudulent activity. Autoencoders are like the minimalist artists of the AI world, capturing the essence of data in its simplest form. They're used in various applications, from compressing images and videos to detecting anomalies in financial transactions. However, autoencoders can sometimes struggle to reconstruct complex data perfectly, especially when the input data is highly variable. They also require careful tuning to ensure they're learning the most relevant features and not just memorizing the input data. Section 6. The future of creation. The world of generative AI is like a rapidly evolving canvas, with algorithms like CNNs, RNNs, transformers, and autoencoders acting as the paintbrushes. Each brings unique strengths to the table, pushing the boundaries of what's possible with AI and redefining how we think about creativity. From generating photorealistic images and composing music to writing compelling narratives and powering intelligent chatbots, these algorithms are weaving themselves into the fabric of our digital lives. As these technologies continue to evolve, we can expect even more creative and groundbreaking applications. The future of creation is here, and it's powered by the magic of generative AI.